Good morning, dear students. Today I am going to discuss about bases and indicators. Dear students, you have already studied about acid. Now I am going to discuss about bases. Generally, we know that bases are bitter in taste, bases are soapy in touch, and bases are the substances which turns red litmus into blue. But in this class, in class 10th, you have to define the bases like this. Bases are the substances which produce hydroxide ions. Dear students, sodium hydroxide, potassium hydroxide, calcium hydroxide, zinc hydroxide, iron hydroxide, these are the examples of bases. Dear students, now we will discuss about the physical properties of bases. But before that, on the basis of concentration of hydroxide ions, bases can also be classified into two parts: strong bases and weak bases. The basic solution which can produce large amount of hydroxide ions are called strong bases. In another words, you can say that the bases which is completely ionized in water and produce a large amount of hydroxide ions are called strong base. For example, sodium hydroxide, potassium hydroxide, these are strong bases. But the base which is partially ionized when dissolves in water and produce comparatively less amount of hydroxide ions are called weak bases. Ammonium hydroxide is the example of weak base. Dear students, now we will discuss about the physical properties of bases. Bases are bitter in taste. Bases are soapy in touch. Bases turns red litmus into blue. Bases becomes yellow in methyl orange. Methyl orange, which is an indicator, and bases turns pink in phenolphthalein solution. Phenolphthalein is also an indicator. Basic solutions are also good conductor of electricity. Dear students, now we will discuss about the chemical properties of bases. Yes, generally all the bases do not react with metal, but some of the specific bases can react with specific metals and can produce hydrogen ions, hydrogen gas. Dear students, it means when base react with a metal, it also produce hydrogen gas. For example, so we can write here base plus metal, salt plus hydrogen gas. For example, sodium hydroxide, which is a base, and metal like zinc. So when sodium hydroxide react with zinc, it produces sodium zincate Na2ZnO2 plus hydrogen gas H2. So we can write the chemical equation like this: 2NaOH plus Zn Na2ZnO2 plus H2. Dear students, this first chemical property is clear now. Generally, bases do not react with metals, but some of the specific bases like sodium hydroxide, potassium hydroxide can react with zinc or such type of metals, and it can also produce hydrogen gas. So when sodium hydroxide reacts with zinc, it produces sodium zincate and hydrogen gas is released. Second chemical properties of base. Dear students, when a base reacts with an acid, it produces salt and water. This reaction is also called a neutralization reaction. So dear students, we can write here base plus acid, arrow, salt plus water. Sodium hydroxide, which is a base, when reacts with a hydrochloric acid, which is an acid, so NaOH plus HCl, arrow, NaCl plus H2O. So we can write here base plus acid, arrow, salt plus water. So we can say that when a base reacts with an acid, it produces salt and water. Third chemical properties of base, about non-metallic oxide. As you know, non-metal oxides are acidic in nature. So dear students, when a base reacts with non-metallic oxide, it also produces salt and water. So we can write here base plus non-metal oxide, salt plus water. We have taken an example, sodium hydroxide, which is a base, carbon dioxide, which is a non-metal oxide, and it produces Na2CO3, which is a salt and water. So equation we can write here like this: 2NaOH plus CO2 arrow Na2CO3 plus H2O. Dear students, these are the main chemical properties of bases. So bases react with metal and it produces hydrogen gas. Bases react with acids and it produces salt and water. Bases react with non-metallic oxide and it also produces salt and water. Now we are going to discuss a new thing, that is indicator. Dear students, indicators are the substances which tells us about the acidic or basic nature of the substance. Indicators have been classified into two parts: natural indicator and artificial indicator. Dear students, litmus paper, turmeric, onion, these are natural indicators, while phenolphthalein, methyl orange, these are synthetic indicators. So natural indicator, if we talk about litmus paper is generally purple in color. It gives reddish color in acidic medium and it gives bluish color in basic medium. Turmeric, which is a natural indicator, turmeric is yellow in color. It remains yellow in acidic solution and it turns pink or reddish, you can say that, turns reddish pink, reddish color in basic solution. If we talk about synthetic indicator, methyl orange is a good example of synthetic indicator. Methyl orange is orange in color and it turns red in acidic solution, and methyl orange turns yellow in basic solution. Phenolphthalein is also an example of synthetic indicator. Phenolphthalein is a colorless solution. Dear students, it remains colorless in acidic solution and it becomes pink in basic solution. So a chart I have prepared here: methyl orange, orange, red, yellow; phenolphthalein, colorless, pink. Dear students, except that you have to study one more topic, that is pH. pH means potential of hydrogen ion concentration. Dear students, potential means power. So pH is a scale developed by Sorensen in 1909. So pH is a scale to measure the amount of hydrogen ion concentration in a solution. Dear students, pH scale ranges varied from 0 to 14. If pH value is 7, it is neutral solution. If pH value is less than 7, it is acidic solution. And if pH value is more than 7, then it will be the basic solutions. Thanks.